Hi everyone, I am the founder of the Grey Blind Owl. Today we will do some exercises about data types, variables, and interactive programming. You can find the task instructions in the description part of the previous lecture. I recommend you to try to complete these tasks on your own if you have not tried yet. In our first exercise, we will make an overall calculator. We assume that there are 2 midterms and 1 final exam. If you are a student, you can change this to your own and use it as a real calculator. You can make it much more useful by modifying it with newly added topics in the future. That is why I chose this example. We will get the 30% of each midterm and the 40% of the final exam. After that, we sum all of the scores and print the total on the screen. Execute, compile and run. We include our library, hashtag, include, bracket, stdio.h, bracket. We create our main function, integer, main, the brackets, and the curly brackets. Now we define our float variables. The grades may be fractional or the result may be fractional. Therefore, the float data types was considered more appropriate for this example. Float, first midterm, second midterm, final, overall, and the semicolon. Now we ask the user for the first midterm and get the note. Printf, bracket, quotes, please enter your first midterm exam score. Quotes, bracket, and the semicolon. Now we will get it, scanf, the brackets, quotes, %f, quotes, comma, address of first mid, the bracket, and the semicolon. We are here. Please enter your first midterm exam score. I will enter 51 here. Now we ask the user for the second midterm and get the note. Printf, please enter your second midterm exam score and the semicolon, and scanf, %f, ampersand, second mid, and semicolon. We do the same thing with the first one. Please enter your second midterm exam score. I will enter 64 here. Okay. We ask the user for the final exam and get the note. Printf, please enter your final exam score and semicolon, scanf, the %f, ampersand, final, and the semicolon. Okay, I will enter here 85. And our overall is equal to this one, 68.50. Our overall is equal to 68.50. We calculate the required percentages and store them in the same variables in order not to produce new variables. Okay, in order not to produce new variables. For example, first mid is equal to first mid times 30 over 100 and semicolon. We do not produce new variable for this value. Okay, we keep the number in the first mid variable. Second mid is equal to second mid times 30 over 100 and semicolon. The final is equal to final times 40 over 100 and semicolon. We calculate the overall and print it on the screen. Overall is equal to first mid plus second mid plus final. Okay, we changed the first mid value here. We do not use the first mid value. We will use the second first mid value here. First mid is equal to first mid times 30 over 100 and semicolon. As you can see, overall is equal to first mid, so this one, the second mid, so this one, and the final, so this one. And we will print it on the screen. Printf overall is equal to the person sign dot 2f for the 2 digits after the dot here, 2 digits, overall, and the semicolon. We finish the program, return 0 and semicolon. In our second exercise, we will make a calculator that calculates the perimeter and the area of a circle. We will take the radius of circle and define a constant for p number. You may have defined a float variable for the variable p. This is what you need to do at this stage. However, today I am going to talk about macros, which is a structure you can use for such constant variables. If you are going to use a number that will not change throughout your entire program, and you will need to use that number with a variable name, macros are best suited for this situation. After that, we will calculate the area and perimeter. Okay, execute, compile, and run. We include our library, hashtag, include, bracket, stdio.h, and bracket. We will define a macro here under the libraries. Usage, hashtag, define comment, define, variable name, and value. Hashtag, define, a blank, variable name, a blank, and value. The blanks are important. If it is not okay for you, you can create a constant in your code like float p is equal to 3.14 semicolon. You can use this in your program. Float p is equal to 3.14 here. Float, radius, area, perimeter, and also p is equal to 3.14 and semicolon instead of the macro. Okay? It is okay. It is not problem. It is not a problem. But I want to show the macros to you, and I want to use a macro for this situation. Hashtag, define a blank, p, our variable name, macro name, a blank, 3.14. Now we create our main function, integer, main, and the brackets, and the curly brackets. Now we define our float variables here. Float, radius, area, and perimeter, and the semicolon. We ask the user to enter the radius of the circle and get it. Printf, please enter the radius of your circle and the semicolon. Scanf, the person sign f, ampersand, radius, and semicolon. I want to enter a float number like 5.14. As you can see, area is equal to this number and the perimeter is equal to this number. We calculate the perimeter and area here. You can also use the met.h library for POW function. You can also use the met.h library for POW function. Please do a research for this function and library and try to organize your code accordingly. Okay? I want you to do a research for this function and library. area is equal to P times radius. I can use here, instead of radius times radius, I can use power function. Okay? I can use the power function. So I want you to do a research for this function. And semicolon. Perimeter is equal to 2 times P times radius and semicolon. We print the perimeter and the area with 3 digits precision to the screen. Printf, area is equal to the person sign dot 3f. Perimeter is equal to the person sign dot 3f. Area and perimeter, as you can see, area is equal to this with 3 digits after the decimal point, and perimeter is equal to this after the 3 digits, after the decimal point, 3 digits here. And we will finish our program, return 0, and the curly bracket. In our third exercise, we will make a first order equation solver. A times x plus b is equal to c. This is the format of a first order equation. We will get the a, b, and c constants from the user. After that, we will calculate the x value. Execute, compile, and run. We include our library, hashtag, include, bracket, stdio.h, and bracket. We create our main function, integer, main, the brackets, and the curly brackets. Now we define our float variables here, float, a, b, and c. These are our constants, and x is equal to 0. This is our variable, and the semicolon. We ask the user to enter the a constant, and we will get it here. Printf, please enter the a constant. This is our format. And scanf, the person sign f, the ampersand a, the semicolon. Please enter the a constant here. I will enter 4 here. We ask the user enter the b constant and get it. The same with the a constant. Printf, please enter the b constant, our format, and scanf, the person sign f, ampersand b, and semicolon. I will enter 5 here. We ask the user to enter the c constant and get it. Printf, please enter the c constant, our format, and the semicolon. Scanf, the person sign f, ampersand c, and the semicolon. I will enter 9 here. As you can see, your first order equation 4 times x plus 5 is equal to 9. So our x value is equal to 1. We calculate the x value here. X is equal to c minus b over a and the semicolon. We print the equation and the result in an aesthetic way that the user can easily understand. Printf, your first order equation, the person sign 3fx plus the person sign 3f is equal to the person sign 3f, and x value is equal to the person sign 3f, a, b, c, x, and the semicolon. We finish our program here, return 0. If you tried doing the exercises last week and were able to get the programs working, you do not have to worry about our minor differences. This week, we have done our exercises on the issues we are responsible for so far, and we will continue the lecture series with our new topic, decision structures. Thanks for your all effort and patience. See you in the next lecture. Stay tuned.